Okay, so today we're going to talk about hyperbolas, and so on page 105 in your book, you'll find these notes. I'm going to go ahead and label some key information for you guys, just like we do on the ellipses. So right here, you can see this is the center. Then on the hyperbola, you have two vertices. And then we have two foci. And the way that I think about it is that I'm going to color in a highlighter and I'll erase it in a second. This is my hyperbola, this piece right here. And this piece right here and this piece right here are called my branches. It's kind of like Pac-Man. The branches, the actual hyperbola itself, want to eat the focus. The distance here from the center up to the vertex is called A. And the distance from the center to the vertex is called A. So this whole piece from vertex to vertex is called 2A. And it's the transverse axis. And then we have the distance from the center up to the foci is called C. And there are these other little dots. I'm not exactly sure where they are on this hyperbola, but I'm just going to draw them, pretend like they're there. These are called the Co Vertices. And the distance from a co vertice to a center is called B. Center to a co vertice is B. So this whole thing in here, from co vertice to co vertice, grab my white. This thing right here, co vertice to co vertices, is 2B, and it's called the conjugate axis. Okay, so let's talk about some formulas. So we have a formula of the hyperbola, x minus h squared, and there's a minus sign in the middle, y minus k squared equals 1. It looks a lot like the ellipse. And here's a squared and b squared. In the ellipse, a always be bigger than b. That's not true for the hyperbola. For the hyperbola, it doesn't matter who's bigger, a or b. But in this case, I know this is a horizontal. Hyperbola because the x right here this x right here came first. In other words, the x is positive. And what I mean by that is this negative sign is applied to the y stuff. So whoever is positive is which way it goes. So if I wanted to write a vertical hyperbola, oops, that is not what I wanted. We'll do this. A vertical hyperbola the y stuff would have to go first. So the y is going to keep the k. This time the x stuff is going to come second. It's still going to equal 1. And the a is always going to be first. But this time, this negative sign goes to the x stuff. The y was positive, which is how I know that it's vertical. The last formula that we're going to need is the Pythagorean Theorem. C squared is going to equal a squared plus b squared. And I just have a little thought. With the ellipse, this is how I keep things straight. With the ellipse, their formula has a plus sign, but the c equals a squared minus b squared has this minus in it. With the hyperbola, the formula has a minus sign, so that means their Pythag part has a plus sign. Okay, so let's jump on to page 106 and let's do some examples. See if I can fit both of these on one screen, so we'll try it. Let's see. Okay, so for example 1, it says find the standard form of the equation of the hyperbola with a foci of -1, 2, and 5, 2. So remember my rules? My rules were that we had to first determine the shape and then its orientation. So we know it's a hyperbola, but let's figure out its orientation. So let's draw this. So -1, 2. So there's a foci. And my other foci is at 5, 1, 2, 3, 4, 5, 2. So I don't know where everything is, but I do know for one thing for sure. I'm going to draw a rough draft. I do this hyperbola is going to go sideways because remember my Pac-Man things have to eat the foci. So let's see. So the foci to foci, remember the center to a foci was C. So foci to foci is 2C. So the distance between these dots is 1, 2, 3, 4, 5, 6. That's 6 long. So 2C equals 6. So C equals 3. And halfway between the two foci has to be the center. So let's go back 3. 1, 2, 3. So my center has to be right there. That's my center. And that center's ordered pair is, we know the horizontal is 2, and it's at a height of 2. This is my H and my K. So to write this hyperbola equation, I need to know A, B, H, and K. I know H and K, and it tells me my two vertices. I'm going to draw those. I'm going to draw on a separate plane. So my two vertices were 0, 2, and 4, 2. So this distance between vertice to vertice, this was 2A. That's 4 long, so 2A equals 4, so A must equal 2. I don't know B, but I can find B. I can use that Pythag. I can do C squared equals A squared plus B squared. 3 squared equals 2 squared plus B squared. So 9 equals 4 plus B squared. So minus the 4, 5 equals B squared. B equals the square root of 5. So I'm going to take all this information that I have, and I'm going to write my equation up top, above the problem. And so I'm going to write my x stuff first because it's a horizontal hyperbola. So I'm going to do x minus 2 squared, because the x, it goes side to side, so the x has to be first and be positive, minus the y minus 2 squared. These two 2's I just used are the center, the HK. A always comes first. The A is 2. 2 squared is 4. And the B comes second. Square root of 5 squared is 5. And this always equals 1. So here is my equation of my hyperbola. Okay, let's do the next one. Let's use red. So I have to equal 1. So I'm going to do 4x squared minus y squared equals 16. Divide everything by 16. I'm going to get x squared over 4 minus y squared over 16. I divided each piece by 16 equals 1. So I know my center is 0, 0 because there's nothing in here with my x or with my y. My a down here equals 2 because the square root of 4 is 2. And my b right here equals 4 because the square root of 16 is 4. C squared equals A squared my 4 plus my B squared. So C squared equals 20. So C equals the square root of 20, which is the same thing as 2 root 5, which is approximately 4.5, about. So let's graph what we have. So I'm going to draw my center right here at 0, 0. And then I'm going to go, let's see, this hyperbola goes left and right because my x is first, my x is positive. So I'm going to go 2 to the right and 2 to the left, and those two things are my vertices. V, V, and this is my center. I'm going to go up and down 4. 1, 2, 3, 4. This is my co vertice. And then down 1, 2, 3, 4. This is my co vertice. And I'm going to draw something. I need you to hear me say this. Listen very carefully. This box that I'm about to draw is not by any means a part of my hyperbola. I am just drawing it as a tool to help us draw the hyperbola. So what I'm going to do is I'm going to take one of my dots and I'm going to draw dotted lines up to my other co-vertices, back over, and then come back down to my vertice, down to my other co-vertice, and back across. Hyperbolas have asymptotes, and these asymptotes are going to go through my box. And so what they're going to do is my asymptote has to go through each corner of my box and through my center. So one of my asymptotes is going to go like this. And this asymptote holds my hyperbola. And the other one goes through the other corner. I totally missed it, but it's okay. Through the center and through the other corner of the box. The last thing I need to draw is my foci. From the center, it says to go 4.5. So 1, 2, 3, 4, and a little bit. That's a foci. And then 1, 2, 3, 4, and a little bit. There's another foci. So my hyperbola is going to touch my two vertices right here. And it's going to be held by my asymptotes to eat my foci. So there you go. Okay, let's go back to page 106 and let's do number 3. So this problem says I need to sketch the hyperbola and find the equation of the asymptotes and the foci. Okay, so we're going to do exactly what we did last time, with a little bit more work. We're going to have to complete the square. And so I'm going to write this, and I'm going to take note before I write this. My y squared is negative, which means my y stuff is going to come second. So this hyperbola is going to go side to side because x is positive. So I'm going to write 4x squared plus 8x minus my 3y squared. No y thing to deal with. And then I'm going to say equals 16 because I'm going to move this negative 16 over to the other side. Pull out a 4, x squared plus 2x plus blank minus 3y squared equals 16. This blank right here is b over 2 squared, and that's my b. So 2 divided by 2 is 1, 1 squared is 1. But when I go to put it on the other side, remember, I have to bounce it back to the 4. So I'm going to put a plus 4 on the other side. Oh, this problem. I forgot about this problem. We're going to fix this problem really quick to make our lives easier. Let's change the problem. I know you can't do this in real life, but I'm sure this is a typo, and I forgot to fix it. We're going to change this minus 3 to a minus 2 so that our problem comes out pretty. Sorry about that. Okay. So this, when we complete the square, is going to be a 4x plus 1 squared minus a 2y squared equals 20. And I'm going to divide the 20 over, so I'm going to get x plus 1 squared over, when I take the 20 and divide it over, 4 over 20 is a 5 minus y squared over 2 over 20 is a 10 equals 1. Okay, so now we can graph this because we know that our center is going to be -1, 0. This was supposed to be a minus 8, so it became a -1, and in here it's a minus 0. And then this thing down here is my a squared, so a is going to equal the square root of 5. I'm gonna grab a calculator really quick. Should be about 2 and some change. It's about 2.2. This is b squared, so b equals the square root of 10, which is about 3.2. And so now we can graph. So my center's at -1, 0. My vertices are 2.2 away, and because my x came first, I'm going to go side to side the 2.2. So over 1, 2 and a little bit, and then over 1, 2 and a little bit. Those two things are going to be my vertices. There's my center. My co-vertices are 3 and some change away, so 1, 2, 3 and some change. 1, 2, 3 and some change. I need to find my c because I'm going to have to find my foci according to the direction. So c squared equals a squared plus b squared. C squared equals my 5 plus my 10. So c squared equals 15. So c equals the square root of 15, which is almost 4. So my two foci are going to be 1, 2, 3, almost 4. That's a foci. And then 1, 2, 3, almost 4. There's another foci. So I'm going to draw my box. Remember, this box has nothing to do directly with your hyperbola. It's just a tool that we use to help us, excuse me, draw it. Oops, hang on. I definitely just drew it from the wrong point. On that side. I went through the foci instead of going through the vertice. So let's try that again. So there's my box. I'm just going to fix the foci that I accidentally erased. Remember my two asymptotes? They go through the corners of the boxes, through the center. So there's one asymptote. There's the other asymptote. And then my hyperbola branches go through the vertices and eat the Pac-Man foci. So now let's finish up the math part of this. So it says that it wants me to find the equations of the asymptotes and the foci. Okay, so for the foci, we started at the center, which was -1. And then we went left and right our c value, so plus or minus the square root of 15, comma, 0. We did not go up or down at all. So there's my two foci. The equation of our asymptotes are on page 105. In the boxes, they are listed there, but I didn't talk about them on purpose because I want to just explain them to you. So grab this really quick. So these boxes help you find your asymptotes. And so I want to show you what we did with the boxes. So right here, we started at the center. So this is a point. And we went up, on this case, B, and over A. If this hyperbola were the other way, if this hyperbola had gone this way, we would have ended up with a box, and we would have gone up A and over B. But the slope of this green piece of my line, the slope right there, the M, is my rise, my B, over my A. And then I have this point right here. My center is a point. So what I'm going to do is I'm going to write the equation of my asymptotes in point-slope form. So if you remember, point-slope form says y minus y1 equals m, x minus x1. My m was my b over a in this case. So to do this, I can say y minus something equals my b value was the square root of 10 over the square root of 5. And before we'd make you rationalize this, but that's not the point of this problem, so we're going to leave it like that. And then x minus something. That something is the center. So my center x value was a -1. So x minus a -1, the minus make a +1. And then this is going to be y minus 0 because the y part of my center was 0. You can clean this up if you want, But there's your equation of your asymptotes. Okay, one last problem. Okay, so it says that we need to find the standard form of the hyperbola having vertices of 3, -5 and 3, 1, and asymptotes of y equals 2x minus 8 and y equals -2x plus 4. So let's first of all figure out which way how this hyperbola goes. So I have vertices of 1, 2, 3, 1, 2, 3, 4, 5, and 3, 1. So because I'm up and down, my y is going to come first. So this is going to be a vertical hyperbola. The distance from vertex to vertex is called 2a. It's the transverse axis. And this distance between these 2 points is 6. So we now know that a equals 3. We also know that halfway between the 2 vertices has to be my center. So I'm going to go down 1, 2, 3. That has to be my center. And the ordered pair of my center is going to be 3, -2. So write an equation of any hyperbola. We need the HK, the center, and the A and the B value. Well, I have A, I have H, and I have K. So all I'm missing is B. So let's think about this. When we do a vertical hyperbola, we have, and I'm going to use the equation of the asymptotes. We know that slope, that slope of the 2 asymptotes is going to be equal to, in this case, it's going to be A over B, because on our box, we would have gone up A and over B. So this slope is going to be A over B. And we know that from this equation, my slope has to be ±2. Okay, so now we're going to put some stuff together. We just proved that A was 3, so I have 3 over B equals ±2. I'm going to multiply the B over, so 3 equals ±2B. I'm going to divide the 2 back the other way, so 3 over 2, or 1.5, equals B. Okay, so now I know my B value, and I know A and H and K, so I can write my equation. This hyperbola is up and down, it's vertical, so the y comes first, so it's going to be y plus 2, because y minus the -2 makes a plus, minus x minus 3 squared equals 1. A always comes first, so 3 squared is 9. And I'm going to leave this in fraction form so it's easier for us to square it, but I would call it 3 squared is 9 over 4. And here is your equation of your hyperbola. And it says standard form, and this is our standard form.